On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to talk about the 6 derivatives of our trig function: sine, cosine, tangent, secant, cosecant, and cotangent. All 6 of the derivatives are listed here, but the only 2 that you really need to know, and then through time you'll start to memorize these, but don't stress about it right off the bat. The only 2 that you really need to know, and the only 2 that I probably will know until the day I die, is the derivative of sine is cosine, and the derivative of cosine is negative sine. If I ever forget these, I can apply the quotient rule and I can derive these derivatives, so therefore I don't even stress about memorizing these. And the more you practice with quotient rule, the better and faster you will become at applying that. So with that said, let's look at tangent. How do we get the derivative of tangent to be secant squared? Well, recall from your pre-calc days, tangent of x is equal to the sine of x over the cosine of x. Notice we have a quotient of 2 functions. Well, if we find the derivative of tangent, which we know is secant squared, is what it says right here, but I'm going to show you how we can get that by finding the derivative of this. And we can do this because tangent is equal to sine of x over cosine of x. Now notice we have a top function and a bottom function. We have a quotient. In a previous video, I gave you a little way to remember that. Low d high minus high d low all over low low. So low means we leave the bottom alone. D high means we take the derivative of the top. Minus high, we leave the top alone. D low, we take the derivative of the bottom. And we put all that junk over low low, which is the bottom squared. So check out the quotient rule. That's how I remember it. Maybe it'll help you. So let's take low. That's the bottom. D high, the derivative of sine is cosine of x. So there's our low d high minus high, leave that alone. D low, the derivative of cosine is negative sine of x. And this is all over low low. So we have cosine of x times cosine of x, which is cosine squared of x. Now, let's clean this up. But again, double check that. Low d high minus high d low all over low low. Simplifying the top, we have cosine squared of x plus sine squared of x. Notice we have that negative sign times that negative sign, so we have positive sine squared of x. And this is all over cosine squared of x. And if we simplify this a little bit further, this is a Pythagorean identity, maybe that you will remember from your pre-calc days. I don't remember all of my Pythagorean identities, but I do remember that sine squared plus cosine squared, or cosine squared plus sine squared, is equal to 1. So we have 1 over cosine squared of x. Applying a reciprocal identity to this, 1 over cosine is secant. So 1 over cosine squared is going to be secant squared of x. And as you can see here, that's exactly what we have up here for the derivative of tangent. You can do something very similar for cotangent, except you're going to switch these two, because cotangent is not sine over cosine, it's cosine over sine. So if you did that same concept here, you would end up getting negative cosecant squared of x. So I challenge you to try that one on your own, but I do want to show you how we can get secant of x, tangent of x, for our derivative of secant of x. So recall, secant of x from your pre-calc days is 1 over the cosine of x. And also we just saw that 1 over cosine squared was secant squared, so secant of x is 1 over cosine of x. Let's find the derivative of this and see if it does give us secant x, tangent x once we simplify it down. So d dx of 1 over cosine of x is equal to, we take our low, cosine of x, d high, the derivative of the top is 0, minus high, d low, the derivative of cosine is negative sine of x, and this is all over low low. So we have cosine squared of x. Now to make it match this, we're going to do a little bit of manipulation, but check it out. So cosine of x times 0 is all going to be 0. Negative 1 times negative sine of x is going to be positive sine of x. And this is all over cosine squared of x. Now watch what I'm going to do here. I'm going to write one of them as sine of x over cosine of x, and I'm going to multiply this by 1 over cosine of x. Now all I really did there was, if we take sine of x times 1, we still get sine of x if we multiply our numerators. Multiplying our denominators, we get cosine of x times cosine of x. Well, that's cosine squared. The reason why I did this is because now we can actually rewrite the sine of x over cosine of x as tangent of x times 1 over cosine of x is secant of x. So as you can see here, even though mine is in a different order than this one up here, we do have the exact same derivative. That's the commutative property. Secant of x times tangent of x is the same thing as tangent of x times secant of x. And again, you can apply a very similar technique to the derivative of cosecant to derive this one. But I do want to share that with you, and you may think that's overkill. Why not just memorize them? But the more you practice this, it's going to make you better at quotient rule. It's going to ultimately allow you to memorize these without you even actually trying to force yourself to memorize them. You do this enough, you'll get really fast with derivatives, plus it just helps you memorize sines and cosines, and it helps refresh your memory on reciprocal identities, Pythagorean identities. All of these things you will continue to use in Calculus 1 and even in future courses. And there you have it, the 6 derivatives of your basic trig functions, and also how to derive some of these that you cannot remember right off the bat. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.